Now this another concept in probability which is a very interesting application. Till now, if you observe, the probability definition depends on the number of elementary events and number of elementary events which are favorable to the event and the number of elementary events which are favorable to the total sample space. Now if you look at what happens if the elementary events is infinite set. Clearly, the definition of probability of occurrence of an event fails if the total number of outcomes of a trial in a random experiment is infinite. If it is not a finite set, then we cannot use the definition. Then a very powerful tool of evaluating the probability is given by a concept called geometrical probability. Let's understand this and understand why the name geometrical. The definition of probability is modified and extended to what is called geometrical probability, also known as probability in continuum, given by, look at this, probability is the measure of the specified part of the region by measure of the total region. So in short, say in a Cartesian plane, if the random experiment occupies say a region which is given by this portion, say this is the total sample space, that is all the elements in this sample space are favorable to happening of or the possible outcomes of the random experiment. But out of this, if a specific region is favorable to a particular event, say we call it E, then wherein both of them have infinitely many possibilities, right? So they both occupy a region. They won't give us the number of, but they occupy a area. Then the probability of this event E is given by area of this yellow colored region, that is a specific region which is favorable to the trial, to that of the measure of the whole region area, that is the total green colored region is the total region occupied by the sample space. Then out of this, the region which is occupied by E is favorable to the event E. Then probability is given by measure of the specific region, that is yellow region, by measure of the total region which is the green colored region. Let's understand this idea by a few very interesting problems. Let P of x denote the probability of occurrence of an event x. Then all the points noted by order pair x comma y, where x denotes the probability of the event A and y denotes the probability of event B, which satisfy the condition P of A union B is always greater than or equal to 3 by 4 and P of A intersection B lies between 1 by 8 and 3 by 8. If you look at this, probability of A intersection B is not a fixed number. It's a range which lies between 1 by 8 to 3 by 8. Similarly, P of A union B is not a fixed number. It's a number which lies from 3 by 4 to maximum 1, because probability of any event should be maximum 1. Now these two conditions implies what are the possibilities out of the given options. Let's observe them first. What are the conditions given? Given P of A union B is greater than or equal to 3 by 4 and also given that P of A intersection B lies between 1 by 8 and 3 by 8. Now let's consider addition theorem on P of A union B. We know that P of A union B should be P of A plus P of B minus P of A intersection B. So from the given inequality, can we rewrite this as P of A plus P of B is greater than or equal to 3 by 4 plus P of A intersection B. But look at this, A intersection B has its own limitations. It always lies between 1 by 8 and 3 by 8. So when P of A intersection B lies between 1 by 8 and 3 by 8, can we rewrite this as this will be always greater than or equal to 3 by 4 plus 1 by 8, which is 6 plus 1, that is total 7 by 8. So what we got here, this condition gives us P of A, that is the x coordinate, plus P of B, that is y coordinate, should be greater than or equal to 7 by 8. This is one of the region. Now again from the same condition, we can also write P of A plus P of B should be less than or equal to 1 plus P of A intersection B, because P of A union B maximum should be 1, which should be less than or equal to 1 plus the maximum value of A intersection B, which is 3 by 8, which is 11 by 8. So P of A plus P of B should be always less than or equal to 11 by 8. But when we convert this to x and y, P of A is nothing but the x coordinate plus P of B is the y coordinate, and this should be less than or equal to 11 by 8. Let's treat this as equation 2. Now when we plot these regions denoted by x plus y greater than or equal to 7 by 8 and x plus y is less than or equal to 11 by 8, how does the region represents? Yes, clearly it is satisfying the condition C that P of A plus P of B should lie between 7 by 8 and 11 by 8. Let's try to mark this region on the Cartesian plane. When we consider x-axis and y-axis, how is the line x plus y equal to 7 by 8? It's a straight line having x-intercept 7 by 8 units and y-intercept as 7 by 8 units. So that will be a straight line which passes through 7 by 8 and 7 by 8. So what is the region denoted by x plus y greater than or equal to 7 by 8? Yes, clearly it should be the region which is above the straight line x plus y is greater than or equal to 7 by 8. How is the line x plus y is less than or equal to 11 by 18? Yes, that is also a straight line which is parallel to x plus y equal to 7 by 8, making an x-intercept of 11 by 8 and a y-intercept also equal to 11 by 8. So that would be a straight line, right? Now x plus y less than or equal to 11 by 8 should be the region which is below that of this straight line. But remember, both P of A, which is probability of an event, and P of B, which is probability of second event, which we are denoting x as P of A, then P of A can never cross 1, right? So the maximum value of x should be 1. So x is always less than or equal to 1. That means what? It should be the region which is to the left of x equal to 1. Not only x, even y value, which is the probability of B event, should also be less than 1. So if we take 1 which is in between 7 by 8 and 11 by 8, this will be the straight line which is y is less than or equal to 1 is a region which is in below this line y equal to 1, right? So what is the total region represented by the given inequations? Yes, the required region is given by this portion which is below the line y equal to 1, above the line x plus y is equal to 7 by 8, but below the line x plus y is equal to 11 by 8, and to the left of the line x equal to 1. So this is a way where we can represent the required region followed by the which is satisfying the given inequations on probability functions. Now let's try one more simple problem to understand this idea, but a very quite interesting problem. Try to understand this. Two persons, Ram and Shyam, decided to meet at a park in the evening between 6 p.m. and 7 p.m. And how is the agreement? The first to arrive will wait for 15 minutes and then leave. Assuming that the two arrive independently at any time during that hour, find the probability that they finally meet. So let's assume that Ram arrives, Ram arrives x minutes past 6 p.m. and Shyam arrives y minutes past 6 p.m. and they both are arriving into the park independent of each other. Now, one clear condition says whoever arrives first would wait for 15 minutes and leave without meeting the other person. So look at this. When will these two people meet? If the difference between the arrival times of Ram and Shyam, that is between x and y, is less than or equal to 15, then only the two people are going to meet. That means for the two people to meet, mod of x minus y should be less than or equal to 15. Now we are using modulus because whoever arrives first, maybe Shyam arrives first or Ram arrives first. That means x or y could be bigger. So whoever arrives will wait only for 15 minutes. That's why the difference of their timings of arrival should be less than or equal to 15. Not only this, because they are arriving and they decided to meet between 6 and 7 p.m.s, can we also say x should be between 0 and 60, because there are 60 minutes in that hour between 6 p.m. and 7 p.m. This is our inequation 2. Similarly, y, that is the time where Shyam arrives, is also clearly a number between 0 and 60. So this is our inequation number 3. Now look at this. These are the total possible values of x and y, which is any time between 0 minutes to 60 minutes past 6 p.m. Similarly, y can also be any time which is 0 minutes to 60 minutes between 6 p.m. and 7 p.m. So what is the total region that is possible for them to meet? Yes, x can take any number between 0 and 60 and y can take any number between 0 to 60. Now let's represent these two on axis so that we know the region where they can meet, that is a possible region of their meeting. Yes, let us consider y-axis as the time of arrival of Shyam and x-axis we denote the time of arrival of Ram. Then from 0 minutes, this is past 6 to 60 minutes. Any time Ram can arrive in between these two. Similarly, Shyam can arrive any minute from 0 minutes past 6 p.m. to 60 minutes past 6 p.m. So this is the arrival zone of the second person Shyam. So what is the total region bounded by these two people? Yes, when x lies between 0 and 60, clearly this is a square with each side as 60 units. So from these observations, first shall we write? Let's call this A, B and C. So what we observe here? Total possible region is the area of the square OABC. What is this total area? 60 into 60, that is 3600 square units is the possible region of meeting of those two people. This is the total sample space. Now, any time of arrival between this total sample space is not favorable. That is favorable only provided mod of x minus y is less than or equal to 15. So let's try to explore this equation, mod of x minus y less than or equal to 15. What are the possibilities for mod of x minus y less than or equal to 15? Yes, it might be is less than or equal to 15 gives rise to two different equations. One is x minus y is less than or equal to 15, or x minus y is greater than or equal to minus 15. Now clearly this is the region which is above the line x minus y equal to 15. Where is this line x minus y equal to 15? It's a straight line having x-intercept of 15 units and cutting y-axis at y-intercept of minus 15 units. So this is a straight line which is joining, wherein this is a height of 45 units. So let's call these points as P and Q. Let's identify both the points. P will have a coordinates 15, 0, wherein Q will have the coordinates 60, 45, because this is a point on the line x equal to 60, but where this line when x equal to 60, here we get y value as 60 minus 15, that is 45. Now similarly, where is the second region? Yes, this is the region which is below that of the line x minus y plus 15 equal to 0. So how is this straight line? It is a straight line making x-intercept of minus 15 units and y-intercept of 15 units. So cutting y-axis at 0, 15, and when extended, this line will cut this line, say R, and at S, then R coordinates are 0, 15 and S coordinates would be on a line which is parallel to x-axis. So Y coordinate would be 0, wherein the X coordinate would be 45. The region should be below that of this line but above that of this line. So what is the final region in which they are possible to meet? Yes, let's calculate that region. That is area of possible meeting is, what is the area? Yes, it is the area of region O, P, Q, B, S, R, O. That means, yes, it's a combination of this triangular area, then another combination of this triangular area, and then the area of this rectangle in between. So let's calculate this total area. This can be written as area of triangle OPR plus area of rectangle PQSR, and then finally other triangle at the top end, that is area of triangle SQB. Now both the triangles being right angles, area of triangle OPR, this is half times base is 15 units into height is also 15 units. Now look at this rectangle. What is the area of this rectangle? It is base into height. What is base length? That is PQ is the base length. Clearly the distance between P and Q is 15 minus 60, that is 45 whole square plus 45 whole square, that is 45 root 2 into the height of the rectangle is also distance between 45, 60 to 60, 45, that is 45 minus 60, 15 whole square plus 60 minus 45, 15 whole square. That means it is 15 root 2 plus again area of triangle SQB, which is a right angle triangle. Therefore, the base is 15 units into the height is 15 units. So 15 into 15 into half added twice. So what is this region? That is 105 into 15. Now we have the probable region as well as the total region. So can we calculate the required probability? Yes. How is the definition of geometrical probability? Probability of Ram and Shyam to meet is the area of the region which is favorable to, yes, the total possible area, and we have calculated both of them. What is area of the total favorable region? Yes, it is 105 into 15 by, what is the total possible area? 60 into 60, wherein the probability is coming to be 7 by 16. So the two people will meet with a probability of 7 by 16. Now if you observe this problem here, we have evaluated the region which is a continuous portion. The person can enter at any time among 6 to 7 p.m. So their possibility region is a continuous region. It's not a finite number of points of favorability, right? But when we calculated this total area which is favorable to their meeting by the total possible area of their arrival. So therefore this is following clearly the example of geometrical probability, right?